Homomorphism as equivalence relation. Just recall the definition of the equivalence relation. A binary relation on a set X is said to be an equivalence relation if and only if it satisfies the following three properties for all A, B, C belongs to X. Number one, this relation should be reflexive. What it means that A is in relation with the same element A. So it means that कि आपके पास कोई भी x का एलिमेंट लें तो वो अपने ही जो भी रिलेशन वहां पे आपने डिफाइन किया उसके साथ हो उस कंडीशन को सेटिस्फाई रिलेट कर रहा है. नंबर टू, दिस रिलेशन शुड बी सिमेट्रिक. व्हाट इट मींस दैट इफ A is in relation with B, then B should be in relation with A as well. So A related in relation with B if and only if B in relation with A. And the third condition, transitive. What it means, if A is in a relation with the element B and B is further in relation with the element C, then it implies that A should be in a relation with C. तो अगर कोई भी रिलेशन जो है इन तीनों प्रॉपर्टीज को सेटिस्फाई करता है तो हम कहते हैं कि ये इक्विवेलेंस रिलेशन है ऑन दैट सेट. नो बेसिकली इस टॉपिक का जो मेन एम है ये शो करना है कि आपके पास होमोमॉर्फिज्म जो है एज अ रिलेशन एक इक्विवेलेंस रिलेशन है. नो वी हैव आवर प्रोपोजिशन होमोमॉर्फिज्म ऑफ टोपोलॉजिकल स्पेसेस इज एन इक्विवेलेंस रिलेशन. नो लेट अस शो हाउ दिस होमोमॉर्फिज्म is an equivalence relation. For this one, I have to consider homomorphism as a relation between two topological spaces and show that it is reflexive, symmetric, and transitive. For the first condition, we know that, so our relation is basically the homomorphism. Now, if I take X, so for the reflexiveness, X should be homomorphic to X. And this is true. Why? Because we have the identity map from x to x. जब मैं यहाँ पे x in relation with x कर रहा हूँ तो it means as a structure wise x की भी टोपोलॉजी वही है और जो दूसरी साइड पे x है उसकी भी टोपोलॉजी सेम टोपोलॉजीज के साथ वो एक दूसरे के होमोमॉर्फिक होंगे. तो आपके पास आइडेंटिटी मैप जो है वो दैट इज अ होमोमॉर्फिज्म. क्यों? क्योंकि आइडेंटिटी मैप आपके पास x टू x बाइजेक्टिव है, कॉन्टिन्यूस है और इसका जो इनवर्स जो कि आइडेंटिटी मैप ही होगा वो भी आपके पास कॉन्टिन्यूस होगा. Number two, this relation should be symmetric. What it means? Let x is homomorphic to y. Now I have to show that this is only happens if and only if आपके पास y homomorphic to x होगा. What it means? It means that there exists some map f from x to y that is homomorphic map. So what homomorphism mean? Homomorphism mean bijective प्लस बाई कॉन्टिन्यूस. यानी बाई कॉन्टिन्यूस मीन कि अब वो एफ बी आपके पास कॉन्टिन्यूस है और एफ इनवर्स भी आपके पास कॉन्टिन्यूस है. सो आई हैव द मैप एफ इनवर्स फ्रॉम वाई टू एक्स. अगर आपके पास एफ बाइजेक्टिव है तो आपके पास एफ इनवर्स भी बाइजेक्टिव होगा. दिस इज अगेन बाइजेक्टिव प्लस कॉन्टिन्यूस. क्यों? क्योंकि ऑलरेडी एफ बाई कॉन्टिन्यूस होने का मतलब क्या है कि आपके पास एफ इनवर्स कॉन्टिन्यूस है प्लस इसका जो इनवर्स मैप है दैट इज अगेन एफ वो आपके पास कॉन्टिन्यूस है. सो दिस इंप्लाइज दैट एक्स इज होमोमॉर्फिक टू वाई if and only if y is homomorphic to x. Now the third one, transitivity. For transitivity, let we have three spaces. X is homomorphic to y and y is homomorphic to z. If x is homomorphic, so it means that there exists a homomorphism from x to y that is bijective plus bicontinuous. And what it means, if y is homomorphic to z, it means that there exists some homomorphism g from y to z such that that is bijective plus bicontinuous. Now consider this map g o f from x to z. I have to show that कि this map is bijective and bicontinuous. We know that F is bijective and G is bijective, so it means that the composition of two bijective map is again bijective. So this is bijective. Then this is bicontinuous. Reason? We know that if we have two continuous map, then the composition of two continuous map is again continuous. So GOF is continuous because F is continuous and G is continuous. And the inverse map, that is F inverse OG inverse, because GOF whole inverse is equal to F inverse composed with G inverse. This map is also continuous. Because F is bicontinuous, it means F inverse is continuous. G is bicontinuous means G is continuous and G inverse is continuous. अब मेरे पास F inverse भी continuous है, G inverse भी continuous है, तो दोनों की composition again continuous. So I have bijective plus bicontinuous map from X to Z. So this implies that X is homomorphic to Z. So we saw the homomorphism relation is basically the equivalence relation. अब आपके पास अगर ये equivalence relation है तो आपको पता है कि अगर मेरे पास equivalence relation हो किसी set के ऊपर, so I can make the equivalence classes. It means that if I have the set of all topological spaces, तो I can make the equivalence classes with this equivalence relation. और हर equivalence class में जितने भी elements होंगे वो सारे एक दूसरे के homomorphic होंगे.